Hi, Ms. Shaw here. Hi, Mrs. Denty.
I'm Mrs. Christian, everybody. Welcome to Seafloor Spreading. I was just saying welcome.
All right, so you're used to looking at Earth in this way from social studies, where you see the oceans. But what we're doing now is we're going to strip away the water and take a look at the features of the seafloor. First and foremost, here in the middle of the Atlantic Ocean, we can see this giant mid-ocean ridge, a 4,000-mile long chain, undersea, underwater mountain chain. This connects right over to here. It's a continuous chain of underwater mountains, and it's called the mid-ocean ridge, where seafloor spreading occurs. Now, we've been talking about continental drift theory. The thing we need to understand is that what moves the continents are actually what happens at the deep ocean trenches. We've been studying the Marianas Trench here, and that's where Challenger Deep is. And these are called deep ocean trenches where subduction occurs. There are many, many deep ocean trenches. I didn't outline them all along the Pacific. We have deep ocean trenches here, along North and South America, just a couple deep ocean trenches here in the Atlantic, and many, many more in the Indian Ocean. And so we're going to take a look at how the deep ocean trenches where subduction occurs drags the continents apart, creating this giant mid-ocean ridge. All right, let's take a look at the actual model. Cut. Hi, okay, so here we are with a model that's going to help us explain mid-ocean ridges and the process of seafloor spreading, deep ocean trenches, and the process of subduction. So let's begin again back at Pangaea. We've all noticed how South America fits into Africa like puzzle pieces. The fossil evidence shows us that the lands were once joined. Little Mesosaurus used to walk across, but at some point, the fossil evidence shows us that they have separated, and we can see the continents as they are today. What drives the process is subduction at deep ocean trenches. So what happens is the ocean floor becomes denser, heavier, and eventually falls down into deep ocean trenches. So we'll start pulling our model and noticing how the subduction is going down at the deep ocean trenches. Let's go back and see what happens. This is going down into Earth, but what's happening here is the continents are separating, magma's welling up at the mid-ocean ridge, causing the seafloor spreading. But we're also noticing a pattern of matching stripes on the ocean floor. These matching stripes are where the magnetic particles in the molten rock line up with north-south, or they'll switch south-north, they switch back and forth in a nice even pattern on each side of the ridge. All right, so we can see how the continents get pulled along by the subduction process. Let's go down and see what's happening within Earth. So underneath, you can see it goes down the sides, it comes down and around, it hits Earth's core. Notice how hot it is. Nice and hot at the core. The rock material then can remelt and is able to then rise and ooze back up out of the mid-ocean ridge, forming new ocean crust and carrying the continents large distance apart.
I just want to point out to everyone that the mid-ocean ridge is the area that is higher up on the ocean floor, okay? It's an underwater mountain range. And we're using the binders here to indicate that it's higher, it's a mountain range. And while the deep ocean trench obviously is a deep place, hence why it's going down at that point. Thanks, kids.